Okay, hey guys, welcome back to Intro Physics. We're currently on our unit of motion. So today I want us to understand the relationship between force, mass, and acceleration. There's a key relationship there. And I want us to be able to use a mathematical model to explain Newton's second law. Okay, so we have been going over Newton's first law, as and we're kind of moving into the second one now. So just for a reminder, Newton's first law is objects at rest must remain at rest, and objects in motion will remain in motion unless acted on by a force. Okay? So basically, if I have a book on the table, it's not going to move. If I move it, it will move. If some other force is applied to it, it will move. It will not inherently move on its own. Same if we have, say, a skateboard. If there's a moving skateboard, it's just going to keep going until it runs into something, or you stop it. Now, let's say it's a Newton's first law. So, we had a lab last time we were in class together. And in that lab, we were observing the relationship between force, mass, and acceleration. So we got some information and then we graphed it. And in our graphic, we noticed a linear relationship between these things, between force, acceleration, and mass. Okay? So we found that the y-axis would be force, so y is the mass, which happened to be our slope was equal to our mass. Our x would be the input here, that was our acceleration, and plus b is 0, roughly. There may be a slight margin of error, but that could come from the fact that we can't eliminate friction in our classroom setting. So some error can come away from that. So we can discuss errors another time, and we kind of discuss them in class. But in general, we get this force equals mass times acceleration formula from these graphs. So this is just a triangle that can help you visualize this formula, especially as we go into space solving for acceleration and solving for mass instead of just force, like we're doing today. But this brings us to Newton's second law, force equals mass times acceleration. So you guys literally did the experiments that you could have done to figure this out. I'm going to move me over here. So we're going to start doing some calculations in relation to force equals mass times acceleration, because this is a mathematical formula. So I want you to start by reading the problem. So you're going to read it and record the values that stand out and what you need to solve for. The next we're going to draw a free body diagram. This is just a visual representation of what is going on. It may seem kind of dumb for these problems because they might be very simple and very easy. So I want you guys to get in the habit of drawing these, because as we get into more complex problems, it's going to be vital to being able to solve those, but it's also going to be required. I know it was required even up into my college time as an engineering student and as a physics student. If you didn't have your free body diagram, you'd have points counted off. And then just plug it into the formula. So we're going to start with our first question, or our first problem. So all the problems are basically the same. There's just some slight changes. So after this one, I'm just going to read the slight changes. Alex is pulling her sister in a red wagon. If Alex is accelerating at a speed of 1 meter per second squared, and her sister weighs 60 kilograms, how much force must Alex use to pull her sister in a wagon? So what information do we have, and what information am I solving for? Those are our key questions. Well, we're given the mass right here. We're given an acceleration here, and we're looking for the force. So then we're going to draw our free body diagram. This is a very simple one that works for me. draw it however makes sense to you. In general, you have the wagon. You can draw a fancy wagon. Just a box is fine. Has 60 kilograms because that's how much weight in the wagon. And then your force. You don't know how much it is. So then we have all our free body diagrams. We have what we need to solve for and the information we have. Now we're just going to plug it into our formula. So mass, 60 kilograms, acceleration, 1 meter per second squared. 1 times 60 equals 60. So force is 60 newtons. Okay. Just a reminder, a newton is a kilogram times meter over per second squared. Okay. But we might not always have acceleration, or we might not always be able to have instant acceleration, but we might be able to have velocity. So just a reminder, acceleration is changing velocity over time. So initial or final velocity minus initial velocity over time. So now we're going to do it in the F equals ma formula. So in this one, we have a constant velocity. Okay, that's 2 meters per second. So I guess I would just get the size, but we have a constant velocity of 2 meters per second, which weighs 60 kilograms, and we're trying to find the force. Okay. So how we draw a free body diagram, and then now we're going to do some calculations. So we have velocity, but we don't have acceleration. So that means we need to convert velocity into acceleration. If we have a constant velocity, that means that there's no change. So it's going to be 0 meters per second. And we're not given time. But that doesn't matter because 0 divided by anything is always going to be 0. So whenever we have a constant velocity, it will always have 0 acceleration. So when we plug 0 acceleration into our F equals ma formula, that will always come out with 0 newtons. So 0 times anything is always 0. Our force will always be 0 if we have a constant velocity. And now with the changing velocity, we have start moving, so it starts at rest, moves for 10 seconds, reaches the velocity of 2 meters per second after those 10 seconds. This is still weighs 60 kilograms, so how much force? So in this problem, we know velocity 1 is 0 because it's at rest, velocity 2 is 2 meters per second, which is given here. It took 10 seconds to get there, so that's speed, and your sister weighs 60 kilograms. And we're solving for force. So we draw a free body diagram. It's pretty much the same for each of these. That's just a visual representation of what's going on. So now we're going to plug the chug. So first, because we only have velocity, we don't have acceleration, we're going to calculate our acceleration. So we're going to do our our final velocity, so 2 meters per second, minus the initial velocity, 0 meters per second, divided by the time. Okay. So that's going to be 2 tenths of the meter per second squared, or 0.2 meters per second squared. Then we can plug into the formula, F equals ma, with 60 kilograms of mass, 0.02 meters per second is the acceleration. That gives us 12, a force of 12 meters. So before class, I want you to complete the Google Form assignment. There are 3 questions or 3 problems on there. 2 are exactly like what you saw. The other one, if you're paying attention in this, you'll be able to solve it no problem. Or the third one. Come to class with any questions you have. If you have immediate questions, feel free to email me. And just remember, you want to read the problem, draw a free body diagram, and then plug in. I hope you guys have an awesome day.